Hello students, welcome to my class. In this video we are going to be discussing about uniform circular motion related problems we are discussing. Let us see the first question. The first question says a 500 kg car takes a round turn of 50 meter of radius. Its velocity is given as 36 km per hour. The centripetal force they are asking. So velocity is given as 36 km per hour. First we need to convert into meter per second. So this is a kmph, kilometer per hour. You need to convert 36 into 1 kilometer per hour equal to 5 by 18 meter per second. 8 into 2 0 will be getting as 10 meter per second will be getting. Now you know the centripetal force formula will be getting as mv square by r. So here the mass of the car is given as 500 kg. Velocity we calculated as 10. So 10 times 100 will be getting by radius is given as 50 meters. And here this is 10 times, so here a centripetal force value will be getting as 1000 newtons you are getting. Let us see the next question. The next question says a body of mass is given as 5 kg is moving in a circle of radius 1 meter. Radius of the circle is given 1 meter with an angular velocity of 2 radian per second. The centripetal force they are asking. Now here you know the relation between linear velocity and angular velocity is V equal to R omega. Here radius is given as here 1 meter it is given with an angular velocity 2 radian per second is given. So that now the linear velocity you got it as V equal to will be getting as 2 meter per second will be getting. Now they are asking the centripetal force they are asking. So here centripetal force formula which will be equal to Fc equal to mv square by r you can take. So mass is given as 5 kg and velocity are calculating as 2204 by its radius value will be 1. So which will be equivalent to here a centripetal force value will be getting as 20 newtons you are getting. This is the correct answer. Now let us see the next question. The next question says here a ball of mass 0.25 kg is attached to the end of the string of length 1.96 meter is moving in a horizontal circle. So here you are taking as a ball you are taking, it's moving in a horizontal circle. This is a ball you are taking, it's moving in a horizontal circle. The string will break if the tension is more than 25 newtons. So here this is a string you are taking and here this is the maximum tension force is going to be acting. 25 newtons is given. What is the maximum speed with which the ball can be moving? So here a maximum tensional force here you will be getting at this point here at the this point. So here a T maximum which will be equal to here will be getting as mv square by r, means here maximum tensional force is going to be providing the centripetal force to move the body in a circular path. So T maximum will be getting as this is 25 newtons which will be equal to here you can take as mass is given as 0.25 kg into velocity is given as this is here v square you need to take. Here maximum speed they are asking. Here radius is given as radius is nothing but length you can take. Length of the string is given as 1.96 meters it's given. So just substitute that value 1.96. So then v square which will be equal to 25 into this is 1.96 by here you can take as 0.25 you can take. So 0.25 you can take as 1 by 4 you can take. 1 by 4 in the sense here you can take as 4 into 25 will be getting as 100. 100 into 1.96 you are getting this is 196. Then here will be getting as maximum speed value will be getting as it's 14 meter per second you are getting. Let us see the next question. A stone of mass is given as 16 kg is attached to a string of length is given as 144 meter long and is whirling in a horizontal circle. The maximum tension in the string can withstand it's given as 16 newton it's given. The maximum velocity of the revolution that can be given to the stone to the string without breaking it they are asking. So the same previous model question student here, maximum tensional force here which we can take as mv square by r we can take. So tensional force is going to be providing the centripetal force to move the body in a circular path. So here the maximum tensional force is given as 16 Newton, which will be equal to mass is given as 16 kg, and here we need to calculate the velocity value. Here radius is given as 144, it's given. We just cancel this one, so velocity with v square equal to 144 will be getting. Then here this maximum velocity will be getting as 12 meter per second you are getting. So this is the correct answer. Let us see the next question. Here a ball of mass is given as 0.1 kg is whirling in a horizontal circle of radius is given as 1 meter by the means of a string at an initial speed of 10 rotations per minute it's given. Keeping the radius constant, the tension in the string is reduced to 1/4 of its initial value, the new speed they are asking. So here initially the mass of the ball is given as 0.1 kg, and here its radius or length is given as it's a 1 meter. It's moving in a horizontal circle of radius is given as 1 meter. Now here initially it's going to be moving the 10 rotations per minute. So here they are talking about the angular velocity. So keeping the radius is constant here, tension in the string is reduced to 1/4 of its initial value. The new speed they are asking. So here you can take tensional force here providing the centripetal force when the body is moving in a horizontal circle. So here the centripetal force, another formula in terms of angular velocity, you can write it as mr omega square. So here omega, here how it is related to the tensional force in the sense omega square is directly proportional to t, you can take. Keeping the radius is constant, of course mass also is a constant value. Omega square is directly proportional to t will be getting. That means here you can take as omega is directly proportional to root t, you can take. So the new angular speed they are asking here, you can take as omega 2 by omega 1, which will be equal to, you can take as t2 by t1, which will be equal to t2 here tension the string is reducing 1/4, t2 becomes t by 4 you will be getting, and initial tension you can take as t, you can take. So here tt gets cancelled, here we will be getting as 1 by 4 under root means 1 by 2 it becomes. So that means here omega 2 which will be equal to, will be getting as omega 1 by 2. So omega 1 here it's given as 10 rotations per minute is given. They are talking actually the angular frequency they are asking. So here omega 2 which will be equal to omega 1 by 2, 10 by 2 you can take, which will be equal to 5 will be getting, it is. So 5 rotations per minute you can take. This is the correct answer. Let us see the next question. A cycle wheel of radius is given as 0.4 meter. Radius is given, it completes one revolution in 1 second. Then the acceleration of the point on the cycle wheel will be. So here a cycle wheel, if it is going to be moving, it completed one revolution in 1 second it's given. The acceleration of the point on a cycle wheel will be. So here acceleration is nothing but when the cycle wheel is going to be moving, it's acting on a centripetal acceleration going to be acting towards its center. So centripetal acceleration, the formula will be equal to v square by r will be getting. So but they are talking about the 1 revolutions in 1 second. They are talking about the angular velocity they are asking. Here in terms of angular velocity, there is a relation between linear velocity and angular velocity, v equal to r omega. So here you can take as r square omega square by r, you can take, on r gets cancelled. One more formula will be getting as r omega square will be getting. So it depends on the question. Here you have to talk whether linear speed is going means linear speed related centripetal acceleration you can take. They are talking about the angular speed, so that you can take as r omega square. So here omega is nothing but here will be getting as 2 pi f. Omega equals will be getting as 2 pi f you can take. It's nothing but here r into here r into omega is nothing but 2 pi f whole square you can take. So which is nothing but here 4 pi square into f square into r you can take. So here radius is given as 4 pi square into f square. 1 revolutions in 1 second. They are talking about 1. Frequency is number of revolutions per second. 1 is given. And radius is given as 0.4 meters is given. So when you are multiplying here, this is AC, centripetal acceleration value will be getting as 1.6 pi square meter per second square you are getting. So this is the correct answer. Let us see the next question. The next question says here, a stone is tied to one end of the string. String length is given as 50 centimeter long and it's whirling in a horizontal circle. So here with the constant speed, in a uniform circular motion, body is going to be moved the constant angular speed. And here this is the stone you are taking, and here length is given as 50 centimeter. This is the length is given. Length is nothing but radius you can take. If the stone makes 10 revolutions in 20 seconds, so that means here frequency is given as 10 revolutions in 20 seconds is given. It's nothing but here will be getting as 1 by 2 Hz will be getting. And here what is the magnitude of the acceleration of the stone they are asking. Magnitude of acceleration is nothing but here there is a centripetal acceleration. In terms of angular velocity, A equal to you can take as r omega square. So AC, which is nothing but radius is given as 50 centimeter is given. So here answer options also is given in CJ system, so we need not convert. So 50 into here you can take as omega value. Omega equals to 2 pi f. It's a 4 pi square into f square you can take. It's nothing but 50 into 4 into pi square into f is nothing but 1 by 2 whole square you can take. It's nothing but 1 by 4. 4 gets cancelled. Here we'll be getting as 50 into pi square you are getting, which is nearly here 50 into here you'll be getting as pi square value will be getting as 9.85. So then centripetal acceleration here will be getting as 493 centimeter per second square you are getting. Let us see the next question. The next question says, if a cycle wheel of radius is given as 4 meter, it completes 1 revolution in 2 seconds, then acceleration of the point on a cycle wheel given will be. So acceleration is nothing but here you can take as centripetal acceleration for a wheel. So it's nothing but r omega square you can take in terms of angular velocity, which is nothing but here r into omega square, in the sense here you can take as 2 pi f whole square. It's nothing but 4 pi square into f square you can take. Here it's given as frequency is given as here 1 revolution in 2 seconds. Frequency is nothing but 1 revolutions in 2 seconds it's given, that is 1 by 2 Hz you can take. So now I just substitute this value. Radius is given as 4 meter into 4 into here pi square into f square, in the sense 1 by 2 whole square you can take. So 1 by 2 whole square means here 1 by 4 and this 4 gets cancelled. So that will be getting as 4 pi square meter per second square you are getting. Let us see the next question. The next question says a mass of 100 gram is tied to one end of the string of 2 meter long is given. The body is revolving in a horizontal circle. String length is given as 2 meter, that's nothing but the radius. The body is revolving in a horizontal circuit by making a maximum 200 revolutions per minute. So here the frequency is given as 200 revolutions per minute, means here you can take as 60. So 2 tens and 2 threes you can take. Here it's nothing but 10 by 3 Hz is the frequency. Now here you are taking as here 100 gram mass is tied at the one end of the string. So here a mass you are going to be tidying. Here its length is nothing but radius you can take 2 meter. It's moving in a horizontal circle, making a maximum 200 revolutions per minute. The other end of the string is fixed at the center. This is a fixed point. The maximum tension that the string can bear is approximately. So maximum tensional force here you can take as T equal to mr omega square you can take in terms of angular velocity. So T maximum, which will be equal to m into r into omega, is nothing but 2 pi f whole square. You can take. Here mass is given as 100 grams. You just convert that one. 100 into 10 power minus 3 into radius is given as 2 meter. 2 2s are 4 into pi square into f square. 100 by 9 you can take. So together when you are calculating all these values, here 2 zeros and it becomes 10 power minus 1 and 1 0, and here also gets cancelled. 2 4s are 8, 8 pi square into, here will be getting as 10 by 9 will be getting. So this value when you are calculating, you are getting as nearly, this is 87.64 newtons you are getting. So this is the correct answer. Let us see the next question. Two masses is given, capital M and as well as small m, are attached to a vertical axis by weightless threads of combined length is given as L. They are set in the rotational motion in a horizontal plane about this axis with a constant angular velocity omega. If the tensions in the threads are the same during the motion, the distance of capital M from the axis. So here you are taking on weightless threads, you are taking. This is a weightless threads you are taking. Thread of the weightless thread of length is given as, combined length is given as, here it's given as L is given. And here it's going to be attached to the vertical axis. Here one vertical axis is given. This is a vertical axis is given, and here two masses you are going to be placing. One mass here you can choose as capital M, and second mass you have to take as small m you can take. This is a weightless thread. Here tensional force is going to be acting on the same thread it is. So same tensional force is going to be acting towards like this. And here now it's going to be making a horizontal circular motion about this vertical axis. This vertical axis is given. Now here about this point, in the sense here this mass will be located at some x distance you can take, and about this point here this axis will be like you can take as L minus x distance you can take. Now here tension it's given as same is given in both the cases. So here you can take as tension is same in the string. So here tension in terms of angular velocity, you know the formula, T equal to mr omega square. So about this point, in the sense here this length is nothing but radius you can take. For about capital M, if you are taking m into omega square into x you can take, which will be equivalent to 2. So m into small m into omega square into, it is about L, radius will be L minus x you can take. So here you can get take cancellation, omega square you have to cancel. Then capital M into x, which will be equal to, you can write it as small m into L minus x you can take. Then here they are asking if the tension threads are in the same, the distance of m they are asking, means x value they are asking. X is nothing but here you can write as so just simplify this one. This is m into x, which will be equal to m into L minus m into x you can take. Here I just simplify this one. When you are simplifying this one, here m plus small m into x, which will be equal to m into L you will be getting. Therefore x value here will be getting as m into L by capital M plus small m. So we are taking here the distance from the mass capital M, which we have taken as small x we have taken, that we have calculated. So small m into L by capital M plus small m. So this is the correct answer. Let us see the next question. Certain neutron stars are believed to be rotating about 1 revolutions per second. If such a star has a radius is given as 20 km, the acceleration of an object on the equator of the star will be there asking. So here you can take here a neutron star, it's going to be rotating. A star is going to be rotating. Here about this is an axis you can take. If such a star has a radius of 20 km, then acceleration of an object at the equator. So this is an equator point you can take. So this is a star you are taking in the sense here. Acceleration in the sense here about this axis here, centripetal acceleration is going to be acting towards its center to the star. Now here it's going to be making as 1 revolution. So omega value is given as, frequency is given as 1 revolution per second is given. Now just calculate here the centripetal force, centripetal acceleration, the formula in terms of angular velocity is omega square r you can take. So omega is nothing but here you can take as 2 pi f, that you have to square 4 pi square f square into r you can take. AC which will be equal to 4 pi square into f square in the sense here we have seen as 1 revolutions per second into radius value here 20 km, you just convert 20 into 10 power 3 you can take. So here when you are multiplying this one, this is 24 is 80. So here AC which will be equal to 8 into 10 power 4. This is pi value also you can take as 4 into approximately this value you have to consider as 10 into this is 20 into 10 power 3 you can take. And here we will be getting as 4 to 8 into here we will be getting as 10 power 5 meter per second square you can take. So this is an acceleration. So here let us see the next question. The next question says here a particle is moving. A particle moves in a circle of radius 25 centimeter at 2 revolutions per second. So here frequency is given as 2 revolutions per second is given, which is nothing but 2 h you can take. The acceleration of the particle they are asking. So in terms of angular frequency here, AC which will be equal centripetal acceleration, the formula will be getting as omega square r you can take. Omega is nothing but you can take as 2 pi f whole square into r you can take. It's nothing but 4 pi square into f square into r you can take. So here this is 4 pi square into f value got it as 2 square is nothing but 4 you can get. Radius is given as here 25 centimeter is given. So just convert the radius value into meters, 25 into 10 power minus 2 you can take. So 25 4s are 100, 100 into 10 power minus 2 gets cancelled. So AC value will be getting as 4 pi square meter per second square you are getting. This is the centripetal acceleration. Let us see the next question. An electric fan has a blades of length is given as 30 centimeter as measured from the axis of the rotation. The fan is rotating at 1200 revolutions per minute. So frequency is given as it's a 1200 revolutions per minute is given. So you have to convert into seconds. So 620 times here the frequency value we got it as 20 h. Length is nothing but radius you can take here which is nothing but here it is given as 30 centimeter. You just convert into meter. Now the acceleration of the point they are asking here, acceleration in terms of angular velocity a equal to you can take as omega square r you can take. Omega is nothing but here you can take as 4 pi square f square into you can take as radius. It's nothing but here you can take as 4 pi square into f value calculated as 20. It's 420 square into radius value. It is nothing but 30 into 10 power minus 2. So here this 2 zeros gets cancelled, 10 power minus 2. So when you are simplifying this one here you are getting as nearly 4732 like that will be getting centripetal acceleration, which is approximately you can take as 4740 meter per second square you can take. Let us see the next question. Two particles of equal masses are revolving in a circular path of radius is given as r1 and r2 respectively with the same speed. The ratio of their centripetal forces they are asking. Centripetal force, the formula will be getting as Fc equal to mv square by r. So here with the same speed they are going to be moving. So here v you can make it as constant. Then centripetal force how is related to the this radius in the sense F is inversely proportional to R you can take. So by making mass also constant, then here you can get it as F1 by F2, which will be equal to, you can take it as R2 by R1 you can take. So this is the value you will be getting. This is the ratio of the centripetal forces, F1 by F2 equal to R2 by R1. Let us see the next question. A particle of mass m is given. It's executing uniform circular motion on a path of radius r. If p is the magnitude of its linear momentum, then the radial force is nothing but centripetal force. They're asking here. Centripetal force, the formula will be getting as in terms of linear speed will be mv square by r. So here m by r you can take. You know the relation between momentum and velocity, p equal to mv. So instead of v you can take as p by m, you have to substitute, into you can take as this is p square by you can take as m square you can take, 1 mm gets cancelled. Then centripetal force, here the value will be getting as p square by here m p square by here m will be there, 1 m will be present in denominator, m into r you can get. This is the centripetal force formula in terms of the momentum. P square by m into r will be getting. Let us see the next question. A mass of 2 kg is whirling in a horizontal circuit by means of a string with the initial speed is given as 5 revolutions per minute is given. That means frequency they are given. So frequency is given as 5 revolutions per minute it's given. Okay, 5 rotations per minute is given. This is a frequency is given. Now here they are asking, keeping the radius is constant, the tension in the string is doubled, the new speed they are asking. So tensional force in terms of the, when the body is moving in a horizontal circle, tensional force is providing the centripetal force. In terms of angular velocity, here the tensional force is mr omega square. Keeping the radius constant is given, so here r is a constant value. So here omega, which will be equal to here 2 pi f you can take. Here mr into omega in essence 2 pi f whole square you can take. Radius of course is a constant value. So you just bring the relation between tensional force and as well as the angular speed you have to take. That's nothing but frequency you can take. Here you will be getting as t is directly proportional to f square you can take. That means f is directly proportional to root t you will be getting. Say f2 by f1, which will be equal to, here you can take as t2 by t1 you can take. So that means here f2 value, when you are substituting here f1 into here t2 by t1 under root. f1 is given as 5 rotations per minute. I am not going to be changing the minutes into seconds. Options is given in rotations per minute alone. So now here keeping the radius constant, the tension in the string is doubled it's given. So here you can make it as 2t by t. Initial value will be t. It's nothing but 5 into root 2 will be getting. It's close to here will be getting as 7 rotations per minute. Let us see the next question. The magnitude of the centripetal force acting on a body of mass m executing uniform motion in a circle of radius r with a speed v is given. It's a direct formula, students. Here if any body is moving in a circular path with a mass m, in the sense here right, if any body is going to be moving in a circular path, here centripetal force, here this is a linear speed you can write as v, and here its radius is given as r it's given, then centripetal force which will be equal to, you can write as mv square by r you can write. Let us see the next question. A string breaks if its tension exceeds 10 newtons. A stone of mass is given as 250 grams. Maximum tensional force is given as 10 newton. A stone of mass 250 gram is tied to the string of length is given as 10 centimeter, is rotated in a horizontal circle. So here a body is going to be moving in a horizontal circle, and here its length is given as here 10 centimeter is given. This is a stone you can take. Length is nothing but radius you can take. Here it's given as 10 centimeter it's given, and here the maximum tensional force is given. So maximum tensional force here, it's nothing but here we will be getting as T maximum, which will be equal to mr omega square, which is nothing but the centripetal force you can take, which will be at the lowest point we will be getting maximum tensional force value. So here with this here we have to calculate the maximum angular velocity. So omega square with this here will be getting as T maximum by m into r will be getting, and here omega, which will be equal to T maximum by here you can take as m into r, you can take under root. So T maximum value is given as 10 newtons is given by here mass is given as 250 grams, you just convert into kilograms, into radius is nothing but length you can take 10 centimeter, 10 into 10 power minus 2. It's an under root you can take. Here this 2 zeros gets cancelled, 10 power minus 2 gets cancelled, and here when you are taking, and this one is 10 power minus 3 just being into the numerator, so it becomes here 10 into, it's 1000 you can take, by here you can take as 25 you can take. So 25 here 4 times it is going, so 4 into 100 will be 400. 400 is nothing but omega value will be getting as 20 radian per second you are getting. Let us see the next question. If a particle of mass is given as m is given, and here it's moving in a horizontal circle of radius is given as r is given, with a centripetal force minus k by r square, the total energy they are asking. Here the centripetal force value is given as minus k by r square it's given. So let us talk about the magnitude alone, students. Here centripetal force here it's always it's going to be acting towards its center, it's a radial force. So mv square by r here it is given as, here I am just talking about only the magnitude, here you can take as k by r square you can take. So here when you are talking here, this is one r gets cancelled, here mv square which will be equal to will be getting as k by r you can take, and here kinetic energy when you are talking, just on both the sides you have to divide with the 1 by 2, so it's nothing but half mv square, which is nothing but k by 2r will be getting. So this is the kinetic energy you are getting. Now let us talk about the potential energy. There is a relation between force and potential energy. Here you can take as F equal to minus du by dr you can take. So du when you are talking in the sense, here magnitude alone you can talk. So du which will be equal to, you can take as this is F into, you can take as dr you can take. Potential energy when you require here, so integral du you can take, integral du which will be equal to, you can take as integral F into dr you can take. So here integral du is nothing but u you can take, potential energy, like you can take potential energy, and here which will be equivalent to here centripetal force already it's given as k by r square it's given into dr you can take. So here k is a constant value, integral 1 by r square dr will be getting as minus 1 by r will be getting. Here also force magnitude I am taking as here not minus k by r square, only I just take it as here k by r square I am taking, whereas in the previous case also here I just consider as only the magnitude. So now the potential energy you got it as minus k by r you are getting. Now here the total energy they are asking, total mechanical energy is nothing but kinetic energy plus potential energy you can take. Kinetic energy you got it as k by 2r minus potential energy is minus k by r will be getting, which is nothing but minus k by 2r you can get. So minus k by 2r is the correct answer. Let us see the next question. A bob of mass is given as 10 kg. It is attached to the wire of length is given as 0.3 meter long. Its breaking stress is given as 4.8 into 10 power 7 Newton per meter square. The area of cross section is given as 10 power minus 6 meter square. The maximum angular velocity with which it can be rotated in a horizontal circle. So here you can take, it's a breaking stress they are talking. Breaking stress is nothing but here you can take as Braking stress is nothing but here you can take as braking force by area. Braking force by area you can take. So it's nothing but braking force is nothing but braking force, which will be equivalent to here you can take as braking stress into area you can take. So maximum braking stress is nothing but here body is moving in a cross-sectional area which is moving in a horizontal circle. In a horizontal circle, when it's moving means here braking force is nothing but centripetal force you can take. Centripetal force which will be equal to mr omega square, which will be equal to, so this is the braking stress into area you can take. Now they are asking the angular velocity omega value. Omega which will be equal to braking stress into area by, here you can take as m into r you can take, this square you have to bring this side, you will be the root. So braking stress value is given as already 4.8 into 10 power 7 it is given, into area it is 10 power minus 6 by mass is given as 10 kg, radius is nothing but length you can take, that is 0.3 meter under root. So just simplify this one. Here 1 10 and 10 gets cancelled, it becomes 10 power 6. 10 power 6 and this 10 power minus 6 gets cancelled. So 4.8 by 0.3, here you just remove this decimal, here 3 16 times it is going. So omega equals will be getting as root over 16. So here omega value will be getting as 4 radian per second you are getting. So 4 radian per second is the correct answer. Let us see the next question. A particle of mass m is given. It moves with the constant speed along a circular path of radius is given as r under the action of the force f. Its speed they are asking. So here, and a body is moving or particle is moving in a circular path. Here its centripetal force is going to be acting, that is mv square by r you can get. Then here with this velocity v square equal to f into r by m you can take. So velocity which is nothing but fr by m you can take. This is the velocity formula. It's a speed, right? Speed they are asking. Look at the next case here. A motorcycle is given. A motorcycle driver doubles its velocity when he is having a turn, and force exerted outwardly will be. So here a motorcycle driver doubles its speed here when he is making a turn. Right here he is riding here. When he is making a turn here, the force exerted outwards will be. So it's an outward force is nothing but will be getting a centrifugal force will be getting. So centrifugal force here the formula will be getting as force exerted outward will be Fc equal to, you can write it as mv square by r will be getting. That means here a motorcycle driver doubles his velocity. So that means here f is directly proportional to velocity square you can take. So then here velocity it is doubling, in the sense here force will becomes 4 times. So here this is force becomes 4 times. This is 4 times is the correct answer. Let us see the next question. A proton of mass is given as 1.6 into 10 power minus 27 kg, goes around a circular orbit of radius 0.1 meter. Here one proton it's given, and here its mass is given, and here it's going to be moving. This is a proton it's given, and here it's under the centripetal force 4 into 10 power minus 30 newtons. The frequency of the revolution of the proton they are asking. Now here when the proton is moving in a circular path, here towards its center, centripetal force is going to be acting. Centripetal force in terms of angular velocity is mr omega square, Fc value, which is given as 4 into 10 power minus 13 Newton it's given. So this is nothing but mr into here omega square, in the sense here 4 pi square f square you can take. Omega equal to here you can take as in terms of frequency 2 pi f you can take. Here they are asking frequency value. This is here which will be equal to 4 into 10 power minus 13. Then with this f square which will be equal to, here you can take as 4 into 10 power minus 13 by, this is mr into, here you can take as 4 pi square you can take. So just simplify all these values. Here 4 into 10 power minus 13 by mass, here it is 1.6 into 10 power minus 27 into this is a 0.1 into 4 into here 3.14 whole square you can take. So if you are calculating this value by taking the square that side, here nearly will be getting a 0.08 into 10 power 8 cycles per second will be getting. So 0.08 into 10 power 8 cycles per second is the frequency value will be getting. Let us see the next question. The radius of curvature of the path of two particles of the same masses are in the ratio 1:2. The radius of curvatures of the two masses is given as R1:R2, 1:2 is given. In order to have the constant centripetal force, their velocity should be in the ratio. So here if they are moving in a circular path, here centripetal force formula F equal to will be getting as mv square by r you can get. So in order to get have the constant centripetal force, so Fc will be same masses it's given. Now just relate the V and as well as R value. V square is directly proportional to R you can take. That means here their velocity should be ratio. V is directly proportional to root R you can take. That means here you can take as V1 by V2 which will be equal to R1 by R2 you can take under root. So here R1 by R2 ratio is given as 1:2 root 2 is given. So 1:2 root 2 is the correct answer. Let us see the next question. An object is moving in a circle of radius is given as 100 meters, and here with a constant speed of 31.4 it's given 31.4 meter per second. What is an average speed they are asking? So here an object is moving in a circular of radius 100 meter with a constant speed is given as 31.4 meter per second. Its average speed for one complete rotation. So here in a circular motion, in a uniform circular motion, so what remains constant in the sense speed remains constant you will be getting. Speed is constant. So here magnitude of velocity which is nothing but will be calling as speed will be calling, and here but velocity direction alone it's going to be changes like tangentially, but the speed always remains constant you will be getting. This is the velocity directions, right? But speed always remains constant you will be getting throughout the circular motion. Speed is a constant value. That means here average speed is equal to the, that means here you can write as average speed is nothing but here will be getting as instantaneous speed alone. Instantaneous speed. So they are asking here average speed. Here at every instant of the time, here the speed will be same will be getting. So here the same 31.4 meter per second is the average speed value will be getting. Its average speed also it's nothing but 31.4 meter per second. Let us see the next question. A body of mass 1 kg is tied to one end of the string, is revolving in a horizontal circle of radius is given as 0.1 meter with a speed of 3 revolutions per second. Assuming the effect of gravity is negligible, then the linear velocity, acceleration and tension in the string they are asking. So linear velocity, the formula will be getting as V equal to R omega. Omega is nothing but here we can write as 2 pi f into R you can take. So here it is given as 3 revolutions per second. That is the frequency is given. Then you have to substitute here 2 into this is 3.14 into frequency you can take as here frequency you can take as 3 Hz you can take into radius value you can get it as 0.1. So which is nothing but when you are simplifying this one you will be getting as 1.88 meter per second you will be getting. This is the velocity speed value. And acceleration they are asking, acceleration here it's a centripetal acceleration you can take. in terms of linear angular velocity here omega square into r. Omega is nothing but 2 pi into frequency will be getting as 3 you can take whole square into r you can take it as 0.1. So its radius is given as 0.1 you can take. So here you can take as 2 3s are 6 pi square into you will be getting as 0.1. So it's nearly you will be getting as 35.5 meter per second square you are getting. Next they are asking tension in the string. They are asking tension is nothing but the right? Tension is providing some centripetal force. In terms of angular velocity you can take as mr omega square. Mass is given as 1 kg. Radius is given as 0.1 meter. Into here omega value you know already, that is 6 pi square. So here 6 pi square you can take. So here it is 2 3s are here will be getting a 6 pi whole square you can get. So here when you are simplifying this one, here nearly will be getting as 30.5 Newton will be getting. So here 1.88, 35.5 and this value 35.5 Newtons will be getting. Or else directly you can take students here A already we calculated tensional force M into A you can take here. Again mass will be 1 kg, nearly will be getting as 30.5 Newtons will be getting. So first one is the correct answer. Let us see the next question. The acceleration of the train traveling with the speed is given as 400 meter per second. As it goes round its curvature of the radius is 160 meters. When it's moving in a circular path here, the acceleration is nothing but centripetal acceleration. A equal to you can take as v square by r. So that speed is given as 400 whole square by radius is given as, radius of curvature is given as 160. So just simplify this one, 4 that 16 into here 10 power 4 by here will be getting as 160. 16 10 times here will be getting as 10 power 3 will be getting. So acceleration will be 10 power 3 meter per second square you can write. Then acceleration which will be equal to 10 power 3 you can write it as 1 kilometer you can take per second square you can take. Let us see the next question. A 500 kg crane takes a turn of radius is given as 50 meter with the velocity is given. With the velocity is 36 km per hour. The centripetal force they are asking. Velocity first you need to simplify students. Here it is 5 by 18 meter per second. 18 2s and 2 into 5 will be getting as 10 meter per second will be getting. So the centripetal force formula, you know, Fc equal to mv square by r you can get. It's nothing but mass is given as 500 kg, velocity 10 square in the sense 100 you can take. Radius value will be getting as 50. So here it is 10 times, so nearly will be getting as 10 power 3 Newtons will be getting. This is the force value, centripetal force value. Let us see the next question. Two bodies of equal masses revolving in a circular orbit of radius is given as r1 and r2, and with the same period is given, time period is given as same is given, then centripetal forces are in the ratio. So you have to bring the centripetal force in terms of the time period, students. So here this is mr omega square you can take. So here m into here r into omega is nothing but here you can take as 2 pi by t in terms of time period. So you can write it as 4 pi square by t square you can take. Now here time period with the same time period is constant. So now here mass also, two bodies of equal masses is given, mass you can make it as constant. So f out is related to the radius in the sense directly proportional to r you can take. That means f1 by f2 which will be equal to, you can write it as r1 by r2. Its radius is given as ratios will be r1 by r2 you can write. This is the correct answer. Next question says here a mass is supported on a frictionless horizontal surface. It is attached to the string and rotates about a fixed center with an angular velocity omega naught is given. If the length of the string and angular velocity are doubled, the tension in the string which have the initially T naught is known. Now here a mass is supporting and here it's moving in a circular path in the sense. Initially the tension in the sense here a centripetal force you can take. So tension force is providing some centripetal force, mr into initial angular velocity is given as omega naught square is given. Then final tensional force you just calculate, T dash you just calculate m into, if the length of the string and angular velocity both are doubled. Length is nothing but radius you can take, students. Here you are going to take as 2 times of its radius, and angular velocity also you are going to be doubling. So here it's nothing but 4 omega, 2 omega whole square, it's nothing but 4 omega naught square you can take. So when you are simplifying this one, it's an 8 times m into r into omega naught square will be getting. Then T dash, which is nothing but 8 times of mr omega naught square is nothing but 8 T naught will be getting. This is a new tension force value. Let us see the next question. A particle is moving in a circle of radius is given as r with a constant speed v. If the radius is doubled, then the centripetal force to keep the same speed should be. So here particle is moving in a circle, in the sense here centripetal force is going to be acting, that is mv square by r you can take. Here it is given as a particle is moving, if the radius is doubled and the centripetal force to keep the same speed, here the speed is given as same, then its radius we are going to be doubling, then they are asking speed how it will be. Radius you are doubling, the speed how it will be, means here you can take, this is so mass you can take same, students. Here the radius you are doubling, in the sense here the force value, then they are asking the centripetal force to keep the same speed. F is inversely proportional to, here you can take as r you can take. That means here to keep the same speed, here velocity will be the same you can take. F is inversely proportional to r will be getting. If the radius you are going to be doubling, in the sense, so or else you can take as f2 by f1, which will be equal to, you can take as r2 by r1 you can take. Here radius you are doubling, in the sense here so force becomes f2 value f2 by f1, which will be equal to, here r1 by r2 you can take, students. This is here you will be getting as, it's nothing but r1 by r2 will be getting, r by here you can take as r by 2, in the sense here you can take as, this is r by 2 you can take. So rr gets cancelled, f2 it becomes the 2f will be getting. So radius you are decreasing half, in the sense here force becomes 2 times will be getting. This is a double. Let us see the next question. A stone tied to the end of the string 1 meter long is whirling in a horizontal circle with a constant speed is given. If the stone makes 22 revolutions in 44 seconds, so here a frequency is given 22 revolutions in 44 seconds, here 2 times, this is 1 by 2 h. What is the magnitude and direction of the acceleration of the stone, they are asking. So acceleration is the centripetal acceleration, students. Here that's nothing but omega square r you can take. Omega is nothing but, here you can take as 2 pi f you can take, 2 pi f whole square into, you can take as r you can take. It's nothing but 4 pi square into f square into, you can take as r you can take. So here you can get it as 4 pi square into f square is nothing but 1 by 4 you can take into radius. Radius is nothing but length of the string, you can take as 1 meter you can take. So here this 4 gets cancelled. So AC, which will be equal to, will be getting as pi square will be getting. So pi square meter per second square. So here centripetal acceleration direction always will be getting as towards its center. Here you can take, here if any particle is moving in a circular path, here you can take centripetal acceleration, here at this one, here AC, and here this is AC, here centripetal acceleration always it's going to be acting towards its center. So pi square meter per second square, and direction is along the radius towards the center will be getting. Along the radius towards the center, third one is the correct answer. Let us see the next question. The next question says find the maximum velocity for skidding of a car moving on a circular track of radius 100 meter. The coefficient of the friction between the road and as well as the tire they are asking. So here when the car is moving in a curved path here, so here maximum force here, so frictional force is going to be acting. Frictional force is going to be maximum frictional force due to the static frictional force will be getting. If maximum frictional force maximum value is going to be providing the centripetal force mv square by r. Then static frictional force F equal to will be getting as mu into n. So here you can get it as when the point of contact in the sense here normal reaction and here weight of the body it's going to be acting towards down. This is mv square by r will be getting mu into n in the sense here you can get as mg, which will be equal to you can get it as mv square by r. You can take mm gets cancelled. Then v is nothing but here you can get it as mu into r into g will be getting. So this is the formula, students. V equal to, you just substitute, coefficient of friction is given as 0.2, radius is 100 and g value you can take as 9.8 you can take. So when you are simplifying this one you will be getting as this 2 decimals you have to cancel, and here by removing this 100, 98 into 2 will be getting as 196. So here v equals square root of 196 means here nearly will be getting a 14 meter per second will be getting. So this is the correct answer. Let us see the next question. A car when it passes through a convex bridge exerts a force on it, right? So here a car is moving on a convex bridge is given, which is equal to, right? Bridge exerts a force they are asking, right? So if the car will be here, let us take car will be present over here, and here at the point of contact in the sense here mg it's going to be acting downwards, and here in a normal reaction it's going to be exerted by the bridge on the car, it will be in upwards. So here the bridge exerts a force on the car which is a normal force you can take. Now here you can get it as it's a centripetal force is going to be acting towards the center, it's going to be acting. So here whereas in this case here you can get it as this is moving right towards the center. So here which force will be greater in the sense here mg will be greater than n will be getting, mg will be greater than n. So net force is providing some centripetal force because the car is moving on a curved path. I'm just taking only at the highest point, I'm just taking, students. F net is going to be mg minus n you can take. This is mv square by r which will be equal to mg minus n you can take. Then n is nothing but here you can get it as mg minus here you can take as mv square by r you can get. So be remember when the car is moving on a concave bridge here it's going to be moving towards its center means here mg should be a greater value than the normal reaction will be getting. That means the bridge exerts a force will be calling as normal reaction. So n equal to mg minus mv square by r will be getting. So this is the correct answer. Because it's moving right towards the gravitational force, so that I am taking as mg should be a greater value. Whereas concave when you are talking it is away from the, when you are taking here concave in the sense it's away from the gravitational force, it's going to be moving. In that case here we will be getting as, so here this is an mg you are taking and this is a normal reaction. In that case here we will be getting as n will be greater than mg you can get. Let us see the next question. A body of mass 100 gram is rotating in a circular path of radius is given as r with a constant velocity. So the work done in one complete revolution they are asking. So here work done is nothing but here it's a centripetal force, it's moving in a circular path. Here you can get it as, so centripetal force it will be getting like this. So for one complete revolution, in the sense, here you can take as the displacement you can take along this direction, and velocity direction also will be getting along the same direction. So here work done by centripetal force, work done by centripetal force, here you can take as always it will be 0 you can, because W equal to Fs cos 90 will be getting, force and centripetal force and displacement both will be perpendicular, so we'll be getting a 0 will be getting. Let us see the next question. An unbanked curve of the radius is given as 60 meter. It's a maximum speed at which a car can make a turn if the coefficient of static friction is 0.75 it's given. It's an unbanked road, it's given, a car is going to be moving. It's a car is going to be moving, and here you can take, and whereas the normal reaction here it's going to be acting like this, mg. So here frictional force is going to be providing some centripetal force, and here you can take as here an outward force is a centrifugal force you can take. Without skidding, in the sense, here a car can make a turn which is nothing but maximum speed. Here you can take as n equal to you can take as mg, and here frictional force is nothing but here you can take as mv square by r you can take. So V maximum they are asking, V maximum is nothing but here you can get it as maximum speed is going to be providing, maximum speed they are not asking here, and maximum speed, yes, the maximum speed is going to be providing by the static frictional force. So F static frictional force, which will be equal to mu into n you can take, which will be equal to mv square by r will be getting. So n is nothing but here will be getting as mg, which will be equal to mv square by r will be getting. Mm gets cancelled with this here, the maximum speed formula will be getting as mu into r into g will be getting. So mu value is given as 0.75 into radius is given as 60 meter into you can take as 9.8 you can take, it will be under root. So here together when you are calculating this value, you will be getting as 21 meter per second will be getting. Let us see the next question. A 100 kg car is moving with a maximum velocity of 9 meter per second across a circular track of radius 30 meter. So the maximum force of friction between the road and as well as the car they are asking. So maximum force of friction is going to be maximum force of friction, which is nothing but it's going to be centripetal force you can take. So here which is nothing but you can get it as F equal to here you can get as mv square by r. Static frictional force is going to be providing. Mass here it is given as 100 into velocity here it will be 9 9s are 81 by radius is given as 30 meter. So here 1 0 gets cancelled 327 times. So here we will be getting as, so maximum frictional force is nothing but it's a 270 Newton you are getting. Let us see the next question. The maximum speed of the car on a road turn of radius is given as 30 meter. If the coefficient of friction between the tires and as well as the road is given as 0.4 will be. The same scenario here, the maximum speed due to the static frictional force will be getting as mu into r into g will be getting under root. So here mu value is given as 0.4 into 30 into you can take as 9.8 under root, which will be equivalent to here you can take as 10.84 meter per second will be getting. This is the maximum speed values. Let us see the next question. The maximum velocity with which a car driver must be traverse a flat curved radius of 150 meter. The coefficient of friction is 0.6 to avoid the skidding they are asking. To avoid the skidding also here the maximum speed the formula will be getting as V equal to here will be getting as mu into r into g will be getting. So static frictional force value is given as coefficient of static friction is given as 0.6 into you can take as 150 is the radius you can take, z value you can take as 10 you can take under root, and here this is a decimal and you have to cancel. Here you will be getting as 150 into 6 here will be getting as 900. So here so 900 under root, in the sense here V maximum value will be getting as 30 meter per second will be getting. Let us see the next question. The coefficient of friction between the tires and as well as the road is given as 0.25. Mu value is given as 0.25. The maximum speed they are asking with which a car can be driven round along the curvature of the radius 40 meter without skidding is. So maximum speed, the formula will be getting as V equal to mu into R into G, you can take V maximum. Mu value is given as 0.25, radius is given as 40 meter into G value you can take as 10, you can take. Here you can take as 25 4s or 100 will be getting, and here you can get it as root over 100, which is nothing but 10 meter per second will be getting. And you just look at the next question. These are all the similar models. A car of mass is given as 800 kg moves on a circular track of radius is given as 40 meter. If the coefficient of friction is 0.5, the maximum velocity with which the car can be moves. So here also the maximum speed, the formula will be getting as mu into R into G, you can get. Mu value will be getting as 0.5 is given, radius value will be 40, and here you can take as G value you can take as 9.8 something you can take, which is nothing but when you are simplifying here this decimal and here this one, here here 9.8 into 40 you can take 98 into 40. So V maximum value together will be getting as 14 meter per second will be getting. This is the correct answer. Let us take next question. A particle describes a horizontal circle in a conical funnel whose inner surface is smooth is given and with a speed of 0.5 meter per second and height of the plane of the circle from the vertex of the funnel they are asking. Here one funnel is given. So this is a funnel shape you can take here. So inside a smooth surface is given, a particle is moving in a horizontal circle, and here this is a vertex you can take. Here it's making an angle theta. Suppose here the particle will be here in the sense at this point here, it's going to be normal reaction, it's going to be acting like this. Here this is a reaction force you can take, and here this is a radius you can take, and here it is theta, means here this value will be theta will be getting, this is a theta will be getting. Now you just resolve this one, this side will be getting as r cos theta will be getting, and here this will be perpendicular to this one will be getting as r sin theta will be getting. So here at this point here weight it's going to be acting downwards, mg. So here r cos theta is going to be providing the centripetal force, which is nothing but mv square by r you can take, mv square by r, and here mg is going to be providing here, this is r sin theta will be getting. If you are simplifying these two conditions, here will be getting as, so here 2 by 1 when you are taking 2 by 1, here will be getting as tan theta equals to, here will be getting as, and this is r gets cancelled, tan theta, this is mg by, here will be getting as mv square by r will be getting, mv square by r will be getting, here mm gets cancelled, so r into g by, here will be getting as v square you are getting. So from this triangle here, from this triangle tan theta, which you can take as, this is the height you can take, height of the plane of the circle from the vertex they are asking. So tan theta is nothing but r by h you can take, opposite side by adjacent side. Here r by h is nothing but r into g by v square you can take, here r gets cancelled. So h is nothing but here with this here, which is nothing but v square by g you are getting. V value it's given as 0.5, 0.5 whole square by g value you can take as 10 you can take. So when you are simplifying this one meters, right here you will be getting as 2.5 centimeter you are getting. Let us see the next question. If a cyclist is moving with a speed of 4.9 meter per second on a level road, it can take a sharp circular turn of radius 4 meter, then the coefficient of friction between the cycle and as well as the road they are asking. So maximum speed formula here the same in circular motion, V maximum, which will be equal to, will be getting as mu into R into G, will be getting under root. So V square maximum, which will be equal to mu into R into G, you can take. They are asking coefficient of friction, mu equal to, you can get it as V square by R into G, you can take. So V value is given as 4.9 into 4.9, radius is given as here 4 meter, G value you can take as 9.8, this is 2 times 2 4s are 8, so mu value will be getting as, so it's a 4.9 by, here you can take as 8, which is nothing but 0.61 will be getting. Let us see the next question. A coin is placed on a rotating turntable. It slips when it is placed at a distance of 9 cm from the center. It's a rotating table is here it is given, and here you are placing a coil, here at this position you are placing a coil, and here this radius is given as 9 cm is given. This is a coin you are placing, and here it's going to be rotating about its axis. If the angular velocity of the turntable to be tripled, it will just slip if its distance from the center is. So here without skidding, in the sense here you can get as without skidding the coin, it has to be rotated in the sense here you can get it as frictional force is providing some centripetal force you can take, provides centripetal force you can take, right? That is nothing but here we will be getting as centripetal force is constant, that is mr omega square, which will be equal to, you can take as constant you can take. That means mass remains constant, mass of the coil. That means R is inversely proportional to omega square you will be getting. It's nothing but here you can get it as R2 by R1, which will be equal to, here you can take as omega 1 square by omega 2 square you can take. Here you can take R2, which will be equal to R1 into here omega 1 by omega 2 whole square you can take, which will be equal to R1 is given as 9, and here omega by here you are taking as triple you are taking. So here whole square, omega gets cancelled, this is 9. So here R2, which will be equal to, this is 1 centimeter. So that means here when you are bringing this coin to the 1 centimeter here, so here 1 centimeter, by rotating the table 3 times, so coil without skidding it's going to be moving. So this is the correct answer, 1 centimeter.